Here we have a problem on intermediate value theorem. Okay, let's go to the information. Check whether intermediate value theorem applies for the given function. If so, find the value of c. So there is a function given over here, that is f of x equals to x square negative x negative 12 and f of c equals to 0 on 3, 5. Okay, so to check whether intermediate value theorem applies for a function, so first we have to make sure the given function is continuous over the given closed interval 3, 5. Since it's a polynomial function x square into x negative 12, it's continuous for all the real values, and also this function is continuous for the values we have in the closed interval 3, 5. Okay, the first condition is satisfied. Now what we need to do is we have to find the value of f of x at the boundary values over the given interval. That is, I have to find the value of f of x at x equals to 3 and x equals to 5. Okay, first let me find the value of f of 3. So that means I have to plug in x equals to 3 over here. Then I'm getting 3 square, negative 3, negative 12. Then I'm getting 3 square is 9, negative 3, negative 12. So negative 9, 9 negative 3 will become 6, 6 negative 12 will become negative 6. Okay, now let me find the value of f of x, the right side boundary value, that is 5, f of 5 equals to, then I'm getting 5 square, negative 5, negative 12. The evaluation of the 5 square is 25. So 25, negative 5, negative 12. So when I subtract 5 from 25, I'm just getting 20, 10, 20, negative 12 will become 8. Okay, so I got f of 3 equals to negative 6 and f of 5 equals to 8. So the value for f of c, that is 0, must be between the two values we found for f of x, the boundary values, that is negative 6 and 8. So here the value for f of c is 0. So we have this 0 between this negative 6 and 8. So the second condition is also satisfied, that is f of 3 less than f of c less than f of 5. So the intermediate value theorem applies for this function. Okay, now let's find the value of c. For that, we can take the condition given over here, that is f of c equals to 0. So here already we know that f of x equals to x square into x negative 12. So f of c means I just have to replace x by c. Then I'm getting x square negative x and negative 12 equals to 0. Okay, now I have to solve this quadratic equation. So in this quadratic equation, the coefficient of x square is 1. I think this quadratic equation can be solved by factoring. So in that case, we have to look at the coefficient of x square. It's just 1. So let's consider the constant term over here, that is negative 12. So now I have to get two factors for negative 12, so that the product is equal to negative 12 and the sum is equal to the middle term, the coefficient of x, which is negative 1. So I think negative 4, positive 3 will work, because when I multiply this negative 4 and positive 3, I'm getting negative 12. When I add them, I'm getting negative 1, which is the coefficient of x. So now to get the two values we have for x, we just have to change the signs of the two factors. So the first factor is negative 4. If I change this negative to positive, I'm getting positive 4. That's the first value for x. And if I change this sign positive to negative, I'm getting the second value for x, that is negative 3. Even though we have two values for x, we have to consider the value of x, which is between this 3 and 5. So 4 is the value we have between 3 and 5. So therefore, x equals to 4 belonging to the open interval 3, 5.